Okay, well, this video here is one I've been asked to produce to discuss 400 grain bullets in the 444 Marlin. Several years ago, or maybe just a few years ago, I asked around at marlinowners.com about what was the biggest bullet that people were shooting out of their 444 Marlin, and nobody had an answer. I knew that when Marlin made the 444 Marlin starting in 99 with a ballard barrel, of course they built them for since 64 with a micro groove barrel, and then in 99 they switched to a ballard barrel, allowing, as they said, for bigger, heavier cast bullets to be fired in the 444 Marlin. But as of that point, the only 400 grain bullet that was available and being used in a 444 Marlin was it's a poor version of it, is because it's old, color's worn out, but it's a Beartooth 405 grain dual crimp groove long flat nose bullet. And that was the only one, and you have to do things like shave the inside of the case and so forth to get this bullet to function per prescription by Beartooth bullets in the 444 Marlin application. I experimented, and I went to mountainmolds.com, and my very first experiment with a 400 grain bullet was this 450 grain ham fist bullet, I called it. You can see it's been dropped on the concrete, so a little dented in, whatever. But I made this bullet. It fired well. It had some fit issues in the front end, but mostly the biggest issue I discovered was that the length of the bullet creates a bulge down into the case, and the longer the bullet, like over 400 grains and above, it creates a bulge long down into the case. And the issue that comes up when you're loading with these, working with these 400 grain bullets in the case, in the 444 Marlin, is your loading port right in through here. These bullets would come in here. Now there's inside the tube in there is a concave area to give more room for the bullet to make the sweep. But ultimately, it is the front edge here and the back edge here, in conjunction with the sweep of that area in the tube, that gives your bullet the angle it needs to feed properly. Well, with the big 400 grain bullets, that bulge catches, this bulge here, catches on the inside of the loop here, inside of this here, and changes that angle just ever so slightly, that the rim ends up getting caught somewhere back here in the back spot. So I started working around that issue. With after the 450 grain bullet, and after a couple incarnations, I came up with the 417 grain huckleberry bullet. Now what I did here is I discovered basically that a big 400 grain plus bullets, if seated down to an overall cartridge length of about 2.495 inches, it will feed in through the port, give or take a couple thousandths of an inch, depending on meat plat size and so forth. It'll feed through the port at that size. And this particular bullet, the huckleberry, was designed with a O-give length that when seated in the crimp groove, it would feed through the feeding gate and function fully in the rifle. The only problem really with that bullet design is essentially we're giving up about 5/100ths of case space, of powder space in the case, to be able to facilitate the shorter length to feed through the loading gate. But this bullet really worked well. It proved to be a around an MOA or better performer in the 444 or in the max velocity recorded out in front of the barrel 15 feet. It was right around we'll call it 1835, recorded in front of the barrel with the max load with this bullet and a reloader 7 powder. I also have been working with the idea of building a bullet to work in the shorter lever evolution cases that come from Hornady with the lever evolution rounds shooting a gummy tip bullet. Well, this particular bullet, I'm calling the raspberry bullet, is a bullet designed to fit that dimensions. It has a longer front drive band to compensate for the difference in the case length. So ultimately, loaded into the LE ammo, it will fire just like a case in a full length, a bullet in a full length case. Now, this has a big, huge 0.375 me-plat. That's 0.375 of an inch me-plat. And that's about as big as you're going to run in a Marlin lever action rifle. So it's a big, huge me-plat. And that also creates a little bit more dimension issues, as you could think of when this thing's loading. That corner right up here, whatever's on the inside corner of there, is going to be one of the contact points that's going to either hinder or facilitate it feeding through that gate. So anyways, I created this round, and then I loaded a dummy load of 2.491 because of the little bit bigger me-plat. I sunk it a little bit deeper, and it fed through my 444P and my 1965 444 with this particular dummy load. But when I went to test it into this particular rifle, once again at this 2.491 of an inch, it was having difficulty feeding it. It wasn't feeding in. Well, I've been working around this issue for a long time, and let's just say another side of me took over, and without any preparation or any really planning, the other night took a file to my rifle, and as you can see, I got some scars here from my display of my haste. What I ended up doing with this file, and I'm still not done with it, and this rifle anyway is going to get Parkerized. So forget about the scratches on and stuff that I did. A guy could do this without scratching their rifle for sure. But what I ended up doing is filing off this was a square edge here, and it's a square edge on the inside of this port right in here. I just rounded off this edge here and rounded off that edge there is all I needed to do. Now, as I said before, I took the file to this particular dummy load at 2.491 of an inch would not feed into that port. Shortly after taking the file to it, I went and took that dummy load, and it fed right in, smooth as can be. So then I got to thinking about it, and I created another dummy load. Now this is the same bullet, the raspberry bullet, but I only seeded it in to dimension of or depth of so it's COL of 2.555, exactly SAMI standards there. So let's take a look at that. And you'll see when I get that sucker down there, it's 2.55, 2.45, whatever. Anyways, it's SAMI size. Exactly SAMI spec, maximum length. And now with that filed edges, just here and there. And of course, as you can see, in this little demonstration here, let me close this up. Put it in half cock safe position there, okay. And I'm going to go ahead and feed this sucker through. As you can see, it's a little tight, big me-plat. But as you can see, you can push it right in there. It feeds, it cycles, and ejects just fine. In the 444, is right now you have, as far as I'm aware, you have two choices. Take your time, use a good file, take your time, and you just round off. Just go ahead, round off this edge here, and round off that edge right there on the inside of the port right up in there, and you will, without having to remove too much material, will be able to feed full SAMI length, COL length, the SAMI standards for the 444 in 400 plus grain bullets in a 444. Or your other option is to building bullets like the the 417 Huckleberry bullet with a shorter me plat for creating a cartridge overall length of about 2.495, and that'll work as well. So anyways, I hope that helps people understand a little bit about the complexities of loading 400 grain bullets in a 444. And again, I will say that I'll point out, I should have pointed this out at the beginning, if you have a micro groove barreled rifle, there really is nothing to be gained from this information for you people that are shooting those rifles at a 444, because as an eye test yesterday, once again, 400 grain bullets don't quite stabilize in a 1 in 38 micro groove barrel. So your maximum bullet weight there is somewhere between 360, 375 in those 1 in 38 micro groove barrels. But for those of you who have a Ballard barreled rifle, 444 Marlin, 1 in 20 twist, or some of the Winchester variations, I can't tell you about the loading gate issues or anything, but these are some of the options that are available to 444 for shooters with 400 grain bullets.